The universe is probably not 26 billion years old. Let's break down this recent news that supposedly redefines the age of the universe. Scientists have been refining how old they think the current universe is, dating it from the moment of the Big Bang, and we've come out at around 13.8 billion years old. That's what the evidence available tells us. But you may have heard of a recent claim that the universe is double that age, around 26.7 billion years old. This paper in Monthly Notices of the Royal Astronomical Society isn't peer-reviewed, but of course it's quickly made headlines as redefining the age of our universe. Look, anything is possible, and it's important to constantly question our assumptions, but let's talk about why it's unlikely that the universe is actually this old. One of the assumptions of the standard model of cosmology, also called lambda CDM, is that light is a constant. So for example, while traveling through space, the wavelength of light might stretch, hence why we can only see light from the furthest galaxies with an infrared optimized observatory like JWST, but the energy of light is not affected. It's a constant. This new model doesn't treat light as a constant. This paper supports the tired light theory, which basically posits that light actually loses energy as it travels through space. This theory was first proposed in 1929 and offers a different explanation of redshift, that galaxies appear to be moving away from us at an accelerating rate. In other words, tired light and the idea of an expanding universe have traditionally been at odds. But in this case, Dr. Gupta has incorporated the two, making tired light compatible with the lambda CDM model and the idea of an expanding universe. Additionally, to make his model work, he's also proposed that the constants that we see as fundamentals, the speed of light, the gravitational constant, and Planck's constant, actually aren't constant. Instead, he says that they change together in a very specific way. In his view, this explains the puzzles that JWST has revealed about the early universe, that galaxies are more massive than they should be, that they're brighter than they should be. It allows for a much older universe with more time to have formed galaxies. Here's the thing though, it doesn't work for a few reasons. First, if the light from distant galaxies did indeed get tired, older galaxies would appear more blurry to us than younger ones, because anything that would cause light to lose energy would also affect its momentum. We can see extremely distant galaxies alongside closer galaxies thanks to a phenomenon called gravitational lensing, which is when an extremely massive object like a galaxy cluster actually bends space and magnifies more distant objects. If you're having trouble visualizing this, think of a bowling ball on a mattress. Whenever we see this happen, there's no loss of sharpness in the more distant galaxies. There's also the matter of CMB. This is basically radiation left over from the Big Bang that's dispersed throughout the universe and dates from about 380,000 years after the Big Bang. This is when the universe had cooled enough for protons and electrons to combine and create the first stable atoms in the universe, called recombination. But if Gupta's model accurately described the universe, the character of CMB would be different. This is complicated, but here's the very basics. CMB comes from a time when the universe was a black body, which means it absorbed all the light and in thermal equilibrium, so it had to radiate the same amount of light or radiation that it absorbed. That light has since redshifted all the way into the microwave part of the spectrum past infrared. But the distribution of CMB photons still retains that original black body character. However, their density has changed. But if this tired light lambda CDM model accurately described the universe, then the CMB photons would still redshift, but their density wouldn't have changed in the same way. The current state of CMB, as we've observed it over the decades, doesn't support the tired light model, even in combination with the lambda CDM model. And this is just scratching the surface. There's other evidence that isn't consistent with Gupta's theory. For example, if the constants weren't actually constant, we'd be able to see that in a lab. And so, available evidence just doesn't support Gupta's model. It's always interesting to ask these questions. What if the universe is older than we think? What if our fundamental assumptions about the universe aren't true? These are important, in my opinion, vital questions to continually ask in order to ensure we have the best understanding possible about the universe we live in. And frankly, there's a ton we don't know, and we're learning new things every day. JWST is shifting what we know about the early universe, and that's great. Scientists and people like myself in the science community love that. But in this case, I think we can safely say that the conventional wisdom about the universe is accurate, and all the evidence we have supports the idea that the universe is 13.8 billion years old, and there's a simpler explanation for what we've seen from JWST.